Okay, so today we are going to cover section 1 of chapter 9. We're going to cover the Pythagorean Theorem. So the Pythagorean Theorem is used for right triangles, and it's the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of the legs. It's also, if you know your ABCs, a squared plus b squared equals c squared. The c is always in this formula going to be the hypotenuse. So it's always going to be the side that's across from this 90-degree angle. So the c will always be the hypotenuse. The a and the b could be switched up. They're just going to be the legs. So whatever you assign for a or whatever you assign for b doesn't matter. However, the c cannot be switched. This will always be your hypotenuse. The next slide has some common Pythagorean triples. So a Pythagorean triple, so these are common Pythagorean triples. And these are probably numbers that you will see assigned to a right triangle a lot of times on a standardized test or an SAT or a PSAT. Sometimes students memorize them. The most common one is this 3, 4, 5. And notice the one right below it is just a scaled up version of it. All they did was take each one of those three numbers and times them by 2. So once you know the basic Pythagorean triples, you can scale them up or scale them down by multiplying each one of the numbers by 2 or 3 to get a larger triangle. Now, when you are assigning these numbers, remember the largest number is always the hypotenuse. So if you were to draw a right triangle here and you wanted to label it with this 3, 4, 5, you couldn't put the 4 here and the 5 here, and then the 3 wouldn't matter. But these two can't be switched. The 5 must always be, the biggest number always has to be across from the 90 degrees. So it's important that when you're labeling your picture, that you always remember to put the largest number across from the 90-degree angle. Another key thing to remember in this chapter, and really in any of the chapters or the things we cover, are your figures aren't going to be drawn to scale. So for example, on the next slide, when I'm doing these problems, they're not drawn to scale. So meaning, even though this side looks like it's bigger, let's say this was a 15 and you would think it's bigger, just know that you can't go by how long the side looks. So always remember your figures are not drawn to scale. So a lot of times on an SAT or a PSAT, they're going to give you questions like this, and they'll have the little right angle, but they may not label the missing side as an A, B, or C. We still use the same formula. You just need to know where the A, B, and C would be located in case they assign it a different letter, like I did here. So in this first example, A, the side across from the 90-degree angle, remember this Y that they're asking us to find is really our C. And then the 5 and the 10, it doesn't matter which one you say is A and which one you say is B. I'll just go ahead and say the 5 is A, and I'll say the B is 10. Again, you can switch them. So now let's go ahead and plug it in. The formula we're using for all three of these is A squared plus B squared equals C squared. Remember, A and B are just the legs, and C is always the hypotenuse. So let's go ahead and replace. So I'm going to do 5 squared plus 10 squared equals Y squared. I need to follow order of operations here, so I need to square before I add. So 5 squared is 25, 10 squared is 100. I'm going to add them and set it equal to Y squared. Now, my goal wasn't to find y squared, it was to ask to find y. So in order to find y, I have to square root both sides. Square rooting a square makes that disappear. So I'm left with y. And then the 125, it's under the radical. But I don't want you to use your calculator. I want you to leave it in simplest radical form. So if, for example, on the test, you tell me that the answer is 11.1 or 11.2 rounded, you would get it wrong. The way that I want to see your answer represented is you're going to do the factor tree here. You're going to break the 125 down, and you're going to leave your answers in simplest radical form. So the correct answer here is y is equal to 5 square root 5. So don't just hit the square root button and then put 125 and tell me it's 11.2. I'm going to mark it wrong. It must be in simplest radical form. Let's try example B. Here we're going to bring back our multiplying binomials. We're going to FOIL. So again, the y again is still the c squared. So this, or the c. So this is going to be our c. I could assign this one as b and this one as a. So let's go ahead and fill it in. I'm going to be doing 5 squared plus y minus 1 squared equals y squared. Now, be very careful here. For this part right here, the y minus 1 squared, what this means is you're going to take this binomial, you're going to write it twice, and you're going to FOIL it. If you tell me that y minus 1 squared is just y squared plus 1, guess what? You just got it wrong because you're going to miss out on a middle term. You need to write it twice and FOIL it unless you memorize the pattern. I find it better if you write it twice and FOIL it as far as memorizing the pattern. Sometimes the patterns confuse people. So what I'm doing here is FOIL, or basically distributive property. First gives me y squared, outside gives me negative y, inside gives me negative 1y, and then last gives me positive 1. I need to add the middles, and this is what I get when I square the y minus 1. Notice, if I would have just done this, I miss out on the negative 2y, which is going to give me the wrong answer in the end. So now let's go ahead and square the 5. So let me go back over here. 5 squared is 25. I just did the y minus 1 squared, so let me write that in there. And it equals y squared. I now need to work on combining some like terms. So I'm going to go ahead and I can add the 25 and the 1. They're on the same side. I now need to try to get my y squareds together. So I could subtract y squared. But when I subtract it, it cancels on both sides. So now I'm left with 26 minus 2y equals 0. I'm going to add 2y. And now I get 26 equals 2y. Divide by 2. And y equals 13. And that's the answer for part B. Let's try C. Again, the legs, or the two sides that form the right angle, these are going to be my A and my B. So this could be A, this could be B. This time my C is 3 square root 2. So let me go ahead and plug everything in. I'm going to be doing x squared plus 3 squared equals 3 square root of 2 squared. So again, here comes my Algebra 1 skills again. I need to learn how to, or remember, how to square that C term. So over here, the beginning part's easy. X squared is just x squared. 3 squared is 9. But now this, 3 square root 2, I can write it 2 times. And then I can multiply outside with outside. And then inside with inside. I can square root that 4. It becomes a 2. And then I multiply and I get 18. Now, shortcut, whenever you multiply a radical by itself, all that does is make the radical disappear. So that's just a little shortcut. I really didn't need to do 2 times 2 and make it square root of 4. Just remember, whenever you multiply the same radical by the same radical, it just makes the radical disappear. It turns it into a perfect square. All right, so now back to my problem. Let me go ahead and move the 9. My goal is to isolate that x squared. And now I need to square root it. And x equals, technically, it should be plus and minus 3, but I do not want a negative side for my triangle, so I'm only keeping positive 3. Next year, when you're solving these in Algebra 2, you will list both answers. But for geometry, we generally only keep the positive answer. Because whenever we're solving these in Pythagorean Theorem, we do not want a negative side length. Yes. Okay. Now we're bringing back our quadrilateral information, what we just took a test on. So here it says, find the length of a diagonal of a rectangle with length 8 and width 4. So let me go ahead and give myself a picture since one was not provided for me. So here's my rectangle. Remember that you should realize that a rectangle is also a parallelogram. So we know that opposite sides are congruent. And also because it's a rectangle, it has 4 right angles. And then now I can draw in my diagonal as well. So I could draw a diagonal this way or the other way. It really doesn't matter. So now by drawing in this diagonal, I've now created 2 small right triangles. So I have a right triangle over here as well as one over here. And again, it doesn't matter which one I use, whether I use the green one or the yellow one, because I'm going to go ahead and also label my sides. So it has a width of 4 and a length of 8. The 4 and the 8, these are my A and B values. So I could say that this is A, this is B, and the diagonal that they're asking me to find, that's going to be my C. So I'm going to go ahead and do Pythagorean Theorem. Again, A squared plus B squared equals C squared. 8 squared plus 4 squared equals C squared. 64 plus 16 equals C squared. 64 plus 16 is 80. In order to find C, I need to square root both sides. So C is equal to the square root of 80, but now I need to break down the 80. So I can choose to do it however way you want to do it. You could do 8 times 10. And then you'd have to keep going because I don't have prime here and I don't have perfect squares. So 2 and 4, 2 and 5. Now, if at this point you realize you've got a perfect square and you got a pair, you could stop. But let's go ahead and just keep going all the way to prime. The 4 needs to still break down to 2 times 2. And then I have the 5. Now that I have all these prime numbers, I make pairs. And when I make a pair, 2 times 2 is 4. So I square root it, it becomes a 2. Let me do it in a darker color. Then another pair of 2's, another 2 comes out. Nothing to pair with the 5, it stays underneath. Everything that paired up and came out, multiply back. So in simplest radical form, 80 is 4 square root 5. Now, if you would have realized that you could have also done 16 times 5, and then realize that that 16 is a perfect square, you could go right to the answer that way as well. The more practice you get with breaking down the radicals, the more, easier they'll be, and you'll see the perfect squares hiding in there. Let's do another application with a rhombus this time. So again, let's draw a rhombus. So I need to know the properties of a rhombus. I know a rhombus has 4 congruent sides. I also know that the diagonals are perpendicular. Which means I now have 4 smaller right triangles. They're telling me that my diagonals have a length of 16 and 30. I also know that the diagonals of a rhombus have been bisected, because that is a property of a parallelogram, and a rhombus is a parallelogram. So I'm going to split one of I could make the 16 go up and down, so I could say this one's 8. Let me do it in a different way. Let's say this one's 8, 8, and then I could say 15 and 15. So now what I'm going to do, I'm not going to work with the whole rhombus here. I'm only going to focus on one of the right triangles. And the missing side of that right triangle is going to be my hypotenuse. So I'm going to be doing, again, a squared plus b squared equals c squared. The 8 is I could say the 8 is my a squared. And then the b squared, or the b, will be the 15. And I'm looking for the c squared. 64, 225. Add them. And now I need to square root them. The square root of 289 is 17. So my hypotenuse is 17, which is also the outside edge of my rhombus. And I know that in a rhombus, we have the 4 congruent sides. So I'll put 17 for all 4 sides. And now to find perimeter, I have to go back and add those 17s. Or just do 17 times 4. And the perimeter of that rhombus is 68. So on your test or quiz, be very careful and make sure you are reading what it's asking you to find. It's not just asking for the side, it's asking for you to find the perimeter. Pretty good? All right, now we're going to bring back our parts of the triangle, our altitudes, medians, perpendicular, bisectors. So again, as we move through the school year, again, anything that we've learned from any prior chapter could be reintroduced back in to the new lesson. So this one, notice that each one of these sides over here have an x. So this tells me that this large pink triangle is actually an isosceles triangle. And when you have an isosceles triangle, the altitude, which is what's drawn here, is also the perpendicular bisector, and it's also a median. So some of those special names that we learned about, it's actually, when it's an isosceles triangle, this line that's going straight down through the middle of this triangle, in addition to being the altitude, it's also a perpendicular bisector. So that means that that 6 is going to get split into 3 and 3. And it's also a median, which hits it at the midpoint. So now, all I have to do is focus on one side of this pink triangle. And I could focus on this side. And I've got a nice little small right triangle. And again, X is going to be my C. So I'm going to be doing, again, A squared plus B squared equals C squared. I'll say the 3 is going to be my A. I could say that the 6 is going to be my B, and then the X is my C. So 3 squared plus 6 squared equals C squared. 3 squared is 9. 6 squared is 36. I will add them. And now to find the value of just C, I need to square root the 45. And I could break the 45 into 9 times 5, which gives me 3 square root 5. And that's the missing value, or the missing side. X equals 3 square root 5. Pretty good? All right. New theorem. This one is the converse of the Pythagorean theorem. And this one states that if the square of the longest side of the triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So basically, if I give you 3 numbers and I ask you to test out, will these 3 numbers form a right triangle, you're going to plug them in to A squared plus B squared equals C squared. So for example, if I gave you 3, 4, and 5, and if I said, tell me if this is a right triangle, again, the biggest number is C, so I could do 3 squared plus 4 squared, and I'm trying to test to see, will this equal 5 squared after I square and add them? If it doesn't, then it's not a right triangle. But when I actually square them and add them, I get 9 plus 16, which is 25, which equals 5 squared, which is 25. So I would say, yes, this does form a right triangle. So this is how you can use the converse, by plugging in the numbers they give you to determine what type of triangle you have. That's Theorem 9-2. Again, we don't memorize the numbers, just what it says. Let's try Theorem 9. The next theorem is the Pythagorean Inequalities Theorem. And this one states that if the square of the longest side of the triangle is less than the sum of the squares of the other two sides, then the triangle is acute. So if C squared is less than A squared plus B squared, then it's acute. So let's try an example of this. So let's say I gave you the numbers 10, 11, and 14. Now, before you even try to test out to see what type of triangle it is, you really should test to see if these numbers even form a triangle. So for example, remember that test was to take the numbers and add them and subtract them. And if that biggest side was in between this sum and difference, which it is, then you knew these 3 numbers formed a triangle. So sometimes you always need to check to see if the numbers actually do form a triangle. And then if they do, then you do the A squared plus B squared and see if it equals or is less than or greater than the C squared. So let's try this one. So C squared, I don't know what it is yet. And then I'm going to add A squared and B squared. So my C squared is always the biggest number. A squared, I'm going to make that 10. B, I'll make that the 11. 14 squared is 196. 10 squared is 100. 11 squared is 121. So now when I go to add these, I get 221. And I can see that c squared is less than a squared plus b squared, making this acute. So when c squared is smaller, it's acute. Yes. We're going to do the same thing for obtuse. If c squared's bigger, then it'll be an obtuse triangle. So the next one, still the inequality theorem. This one states that if the square of the longest side of the triangle is greater than the sum of the squares of the other two, then it's obtuse. So here, if c squared is greater than a squared plus b squared, then the triangle is obtuse. Let's try some numbers. So let's say let's do 15, 20, and 26. Now always first double check that it does form a triangle. So take the two smallers and add them, subtract them. 35 and 5. 26 is in between 5 and 35, so yes, these will form a triangle. So now let's see what kind of triangle it is. So again, I would take the 26, square it, 15, square it, add that to 20 squared. 26 squared gives me 676. 15 squared gives me 225. And 20 squared gives me 400. So when I add these, I get 625. And you can see that 676, the c squared is bigger, making this obtuse. Now we're going to try some examples of what I just did. Yes. All right, everybody ready? All right, so the first one, again, they want us to decide, are these sides, are they going to form an acute, a right, or an obtuse? Now, again, always take the numbers, add and subtract them, do a quick check to see if the biggest number is going to fall in between. So when I add 21, so just to do my quick check here, 20 plus 21, that gives me 41. And when I subtract them, I get 1. 29 will be in between, so they do form a triangle. So let's go ahead now and check. Remember, the biggest number is always c. So 29 squared, 20 squared, plus 21 squared. 29 squared is 841. So I don't know what's going in here yet. 400, 441. And when I add them, I can see that the two sides are equal, making this triangle a right triangle. A little fun fact, everybody probably already knows that 12 times 12 is 144. And then if I flip the 12 and make it a 21, I can also flip the answer. It's a little fun fact. You like playing around with numbers and see different patterns. All right, so now on to the next one. Again, double check it. 20 plus 21 is 41. Subtract them, you get 1. 30 is in between. These are good. So now let's take 30. We're going to square it. 20, square it, and add it to 21 squared. Well, I just did this one. I got 841. So 400 plus 441 gives me 841. So now I just have to square the 30, and that gives me 900, making c squared larger. So this is going to be an obtuse triangle. Try part C. Again, add and subtract the two smaller numbers. 6 minus 5 is 1. 6 plus 5 is 11. 8 is in between here, so that's good. It does form a triangle. So now let's plug it in. 8 squared. Let's see what relation it has to the 5 squared plus 6 squared. 64. 25 plus 36. 25 plus 36 is 61, making c squared larger, so this one is obtuse. So without even measuring any angles, I can use the side lengths to decide what type of triangle this is. Let's try the next one. So again, now the easiest way to deal with these radicals, so this is part D, 4 radical 3, and 8. Now, in this one, they've already been put in order for us from least to greatest. But what if I didn't know how big 4 square root 3 was? What I can do is square each of these, and then I'll know if 8 is actually the biggest number. Now, you could also approximate it, but it's a lot easier just to square them. So 4 squared is 16, 8 squared is 64. When you square something like this, what we're doing is we're squaring the 4. So really what we're doing here is 4 square root 3 times 4 square root 3. And I get outside is 16. And then I multiply the two insides. I would get a 9. And then square root of 9 is 3. And then I can multiply this. So 4 square root of 3 squared is 48. So here are my numbers now, 16, 48, and 64. So they're already in order, least to greatest. So let me go ahead now and do Pythagorean Theorem. I can just plug them in here now. So I'm trying to do c squared, see what kind of relation a squared plus b squared. So c squared was the 8. We already saw it was 64. A squared I could say is the 4. And then the b squared I could say is the 4 root 3. So 16 plus 48. And then now when I add them, I get 64 equals 64. So this is a right triangle. So be able to square something that's got a square root in it. Understand how to do that. And now the last one. Let me come over here and do it. So again, we can square this to make sure that it is the biggest side. Whenever you square something that's under a square root, it makes the radical disappear. Squaring a square root makes it come out. So the square root of 10 is the biggest side. And if you think about it logically, the perfect squares are 1, 4, 9, 16. Square root of 10 is in between the two perfect squares of 3 and 4. So the square root of 10 is about 3.1 or about 3.2. So let's go ahead and let's just do this one. So I'm doing c squared, which is the 10. I don't know its relationship to the 1 squared plus 3 squared. So when I square the square root of 10, it comes out. 1 squared is 1, 3 squared is 9, 10 equals 10. This is a right triangle. And the last slide is just a summary of these three things. So remember when c squared equals a squared plus b squared, it's a right triangle. When c squared is smaller than a squared plus b squared, it's acute. And when c squared is larger, then it's obtuse. So that's just a little summary. So this is all of the notes now for 9.1.